I'm Elliot Meyerson, and I'm an AI research scientist at Cognizant's AI Research Lab. Today, I'll be discussing our recent NeurIPS paper called Unlocking the Potential of Global Human Expertise, which introduces an evolutionary AI framework called RHEA. And the premise starts from the observation that solving societal problems at a global scale requires collecting and integrating ideas and method from very diverse sets of international experts. And as this set of knowledge becomes larger and more diverse, integrating it and recombining it and discovering the best synergies becomes more and more challenging. And we argue that AI can play a critical role in harnessing the full potential of this expertise. And this solution to this problem must meet some key requirements. It has to be general and that it has to be able to accept expertise in wide variety of disparate forms. It has to be multi-objective and that there's going to be all these different trade-offs at the societal level, costs and benefits. And it has to be traceable in the sense that human contributions actually led to those final results in what amounts so that we can give credit back to those experts who contributed. The RHEA, for realizing human expertise through AI, the framework that we introduce, solves this problem in 4 steps. 1, define a formal API so that users can submit their knowledge as long as it satisfies this API. Gather, so actively going out and soliciting experts to come up with models and knowledge that fits this API and submitting it. And the 3rd step is distilling this knowledge of whatever form into a canonical form using gradient descent into a neural network. And then 4, evolve, where we take these distilled models and evolve them further with evolutionary AI to discover a set of optimal trade-offs. First, in the paper, we show in illustrative theoretical domain that this approach has some fundamental advantages compared to standard approaches of combining models like ensembling and mixture of experts. It also, in this kind of theoretical domain, has some nice properties compared to just running evolution alone or multi-objective reinforcement learning. But the main application in the paper is to this big international XPRIZE Pandemic Response challenge that we designed in collaboration with XPRIZE and some other partners, where the goal was for folks to come up with decision assistant models to help government policy decision makers implement non-pharmaceutical interventions and intervention policies during the COVID-19 pandemic. In this challenge, there were over 100 teams, over 23 countries, I think, were represented. And it resulted in 169 prescriptors, these decision-making assistants, getting submitted. So we took the results from that after it was over, ran RHEA on that, and what we find is RHEA gives very good results compared to the submitted models alone and compared to, say, just running evolutionary AI from scratch. So we get this evidence of this synergy where these diverse ideas submitted by experts lead to new discoveries that wouldn't be available from AI or humans alone. We also see that the method behaves as expected. If we look at the behaviors projected into a 2D space, we can see that the submitted models create this scaffolding on which RHEA elaborates, whereas we just run evolution from scratch, it's much more discordant and doesn't reach these more interesting solutions. And this is evidence that we really do want to go out and solicit this diverse knowledge. Going out and gathering a very diverse set of solutions in different forms can be critical to making some really cool discoveries. So this was really just a proof of concept. I mean, the general principles behind RHEA, it can be applied to kind of any of these large-scale problems that are within the UN SDG goals. And we're working on building a platform called Project Resilience to help generalize this approach. Of course, when we go out and deploy these things in the real world, there's going to be a bunch of ethical concerns when we're making policy decisions, and there's an extensive discussion in the paper around that. RHEA has some great advantages there, and that you can trace the evolutionary trajectory of where solutions come from to see if there's any bias in who submitted those models. But there's some kind of pitfalls that can't really be avoided, and it's critical to still keep humans in the decision-making loop at this point. So anyways, yeah, please check out the paper. We're very excited about this approach and further applications that it makes possible.